Okay, so I wanted to go over the history of database design just because it's the team I'm working on for this sprint or for, excuse me, for the semester. And I'd like to get pretty good at it and understand the history. So, in the history, there's really three main designs. There are three styles of design. There's the first one is called hierarchical, and it was started in the 1950s, 1960s. Yeah, hierarchical it was a tree structure. So yeah, just like any other tree, you'd have a root, and that root would have children. Some of the rules they'd follow is a parent can have multiple children, but a child can only have one parent. And so this is kind of what it would look like. So as you can see, all these children have only one parent. Um, and thing with this one is it's efficient because just like we've learned from our algorithms class, we know that if we want fast performance, it's good to use trees because they split the data in half. If you're using a binary tree, at least it splits the data in half each time, so you're looking at less and less data. So that's good. It is efficient. Some of the issues you're going to see is you're going to need to duplicate data a lot just because of the structure, and it's a little rigid. It's hard to it's not super easy to edit data if you want to change the database often. It's not a very good structure. So that's hierarchical. And basically the reason it was not ideal is just because it's too rigid. It was efficient, but because it wasn't easy to update, we moved on to um, a different structure. And this is more advantages. ChatGPT, all this stuff, all this text, just to be clear, I got from ChatGPT. Um, so some of this stuff is extra, but so anyways, moving on to the network model. Network replaced the hierarchical in a sense. It didn't totally replace it. I mean, there's still hierarchical models, there's still network models today. But both of the network and hierarchical are going to be not nearly as common as another one, which we're about to get into. But anyways, network is similar to the hierarchical with some key differences here. This is kind of what it looks like. As you can see, it is kind of sort of a tree structure. But its network is, from my understanding, it's all about pointing to things. So you can see this is something you wouldn't really see in the hierarchical model. This organic is kind of pointing to a bunch of different things, and and organic is pointing to some other things. And there's some overlapping pointers. That's something you wouldn't really see in the hierarchical model. This non-organic is pointing to limes and lemons, but organic is also pointing to limes and lemons. So uh, you can have um, two different parents pointing to the same children. So that's one of the differences. It's a little more flexible. Um, so it does look like a tree, but it's not quite a tree. It's more, like I said, a bunch of pointers, and so that's why they call it a graph. You have many relationships. That was a new thing. It's like I mentioned in the graph above. And yeah, that's kind of where we're at. Some of the disadvantage of it, it's just complex. It's a lot going on, pointers going all over the place. And I think probably the biggest one is the second point here, this lack of standardization. If you want a technology to be commonly used, it's got to be standardized. Otherwise, it's going to be a little too chaotic. Yeah, so that brings us to the relational model, 1970. We think Edgar F. Codd, who came up with this, from my understanding. He may not be the only one who developed it, but that's what ChatGPT told me. And what I know about the relational model is how it differs from the other two. The relational model is going to store things in tables. Um, the relational model is going to have duplicate data, but that duplicate data will be in the form of keys. So if we go back up to the network model and compare it, the network model It has pointers, and they don't duplicate any data. Um, they just point to the same. They just reuse the same data, and they just put more pointers to it. So that there's not like five different lemons or five different limes. There's one single one, and they just have more pointers to them from other parts of the database. But relational works in tables, and where you are duplicating data is these keys. You have primary key, so member ID would be the primary key of this member table, and then foreign keys, this driver ID would be the foreign key. And foreign keys are basically they're pointers to a primary key of another table. So tables that point to tables. And this is just a lot more organized. Well, I guess you could debate if it's organized, but I think it's more organized because the tables are only storing information related to the tables. And the way you get data from other tables is by these keys. And so it is it is a little bit bigger in storage than maybe the hierarchical, but the advantages outweigh it. So that is why the relational model is the most commonly used today. And that's what I got.